Hey, welcome back. So let's get on to implementing our own version of binary search. So again, here's the pseudocode. First, I just need to make a spot to actually write the code. So I've already done that. I'm doing it as a snippet again. I'm calling mine search binary. It really doesn't matter. If I were you, I'd probably do this in a file somewhere, save it on your computer, but this is easier for me. So I'm going to define our function. All that we said was that it needs to accept a sorted array and a value. So I'll just call mine binary search. Hopefully this is large enough. Let's see, shrink some of this down. Okay. Binary search takes in an array. We'll just call it ARR. And then the value, I'll call it element or LM. So for example, we should be able to call it with, let's do something relatively short, 2, 5, 6, 9, 13, 15. Almost all odd numbers. Let's do 28. Okay. And then let's say that we're looking for 15 in there. All right. So right now that's obviously not going to work. Next, we need to set our left and right and middle pointers, or I'm going to call them, I kind of prefer start and end and middle. And what we want to do is set the start to be here, the very beginning. Every time we don't want to exclude any of the array. So we always want to start at the beginning. So that's easy. Just make a variable, call it start equals index of 0. Then I'm going to make end. And end is going to be the length of the array, but we need to do -1. Otherwise, we're going to be out of bounds. So we want this index, which is it 6? 0, 1, 2, 3, 4, 5, 6. Yes. So 0 and 6. And then we need to take the middle. And this is just to begin. And the middle is just the average of those two. So in this case, 0 and 6, the average is going to be 3. 0, 1, 2, 3. So that's going to give us this position 3. But if we had one more item in here, like 30, then that throws everything off. So if I just had start plus end, and I need to add parens to do the average. Otherwise, it will just be start plus end divided by 2. This case, it's the actual average of them. But if we take a look, we're going from 0 up until 7 now. The average is 3.5. There's no index of 3.5. 0, 1, 2, 3. It's going to be right in between 9 and 13. That's not going to work for us. So that's where I'm going to do math.floor of that whole thing. You could also round up if you wanted to. You just need to be consistent in what you pick. Okay, so at this point, this is what we're looking at with this exact array. We start is going to be set to index of 0, which is right here. Then we have end is set to index of 7 in our case, which is now 30. And then the middle is going to be index of 3.5 rounded down, which gives us 3, 0, 1, 2, 3. So we have 9. And just to verify, we could do a console.log start, middle, end, like that. And if we execute this, did I get anything? There we go. 0, 3, 7. So that's what we expect. Now we get into the actual logic. Well, what we want to do here, we want to continue to loop and repeat this process where we select a middle. Well, first we need to check if the middle is correct, right? Right off the bat, we could have picked 15. We didn't. We're working with 9. But let's say we were looking for 9. We picked the middle of 9 right away. So we need to check if we got it right. And if we didn't, are we greater or less than? Are we looking, is 9 too big or is 9 too small? In which case we need to start searching over here only, or start searching only over here only. So let's start with just the simple while loop. So I'm just going to loop over and over while the element, or while array middle is not equal to what we're looking for. So while the middle is wrong, let's put it that way. So this first time, middle is 9. That's not what we're looking for. We want 15. So we're going to repeat this code. Now the code that we're going to do, first we're going to check. We can assume if we're in here, that means that the middle is either greater than or less than. If the number we're looking for is less than the middle, so if our middle is 9, let's say we're looking for 6. 6 is less than 9. So what we want to do is shift our end down to 6 now. Now you might think we could shift the end to 9, and that would work, but it's redundant because we know that 9 is not the answer already. We checked it. So we're going to set the end to be middle minus 1. So this is our new window. Likewise, the other direction, like in this case with 15, We check 9, that's too small. So we're going to move our window all the way up to here. So our start is now 13, and our middle is going to be 15 or 28. We'll round down, so it will be 15. So we want to do middle plus 1 or middle minus 1 because we've already tested the middle. So let's do that now. I'm going to have a simple if statement. If the element is less than array of middle, like that. If that's the case, like if we're looking for 6, we're going to set the end. We're moving the end down to here, right? So end equals middle minus 1. And then we have else. There's only one other choice, because if it's equal, if we actually got it right, then we're out of the loop. But we haven't gotten it right, so we're either greater than or less than. So else, that means that what we're looking for, in this case 15, is greater than 9. We need to move the start of our window to 13. So start equals middle plus 1, just like that. Then the only other thing, well, this isn't the only thing, but another thing we need to do is now change our middle value. We just need to recalculate it. So our first time through, let me just copy this. This is what we started with, and then we checked it. So array middle is not equal to element, right? 9 is not equal to 15. So is the element less than array middle? Nope. So skip this. Else start equals middle plus 1. So middle plus 1 is 13. So that means that our start is now 13 here. Our end is still 30. It hasn't moved. But we need to recalculate the middle. So we need to average 13 and 30. Well, not 13 and 30. We need to average those indices, which is going to be, what are we at? 0, 1, 2, 3, 4, and 7. So I'm just going to copy this exact same line without the var in that loop. We just get a new middle. So now middle is going to be math.floor of 4 and 7. So that's what, 11 divided by 2. Floored is going to give us 5, index of 5, which is this item here. So this will be our new middle. And just to verify that, let's move this line into the loop so that we see what we get each time through. Okay, so I'm going to run this now. Let me clear my console. Make this a little bit bigger. Okay. And, oh, it looks like it's only running once because at the end, we got the answer correct. So I picked the example of 15 was too easy, but you'll see at the end, it's 0, 3, 7. So that's what we have, 0, 3, and 7 indices. Then it updates to go from 4 to 7, which is what we have here. And the middle is 5. And what do you know? That's what we're looking for, 15. So we broke out of the loop because array middle is now equal to the element. Now if I pick something else, let's say I pick 28 this time, we'll get an extra step. Execute it again. There we go. 0, 3, 7, same thing. But this time 28 is greater than 9. So our window now is from here to here. And the middle is 15, which is what we checked. And that's too small. So then we have another iteration. And in this case, it's too small. So what do? We shift the start up again. Let me get rid of the M. And the start now goes to 28 here. Our end is 30. And our middle, when we take the average, we're going to round down. So our middle is also here. So it looks more like this. And that now means that we've guessed the number correctly because our middle is 28. And you can see that our middle is index of 6, our start is index of 6, our end is index of 7. We've found it. So at the end, what we should be doing, for now at least, is just return middle. And if we test this all out, we're returning 6, index of 6, and that's correct when we're looking for 28. If we're looking for 5, we're returning index of 1. That's correct. There's a big problem with our code, though. And the problem is if the number isn't found in there, our code doesn't handle it. And I'm not going to do this. I recorded this video once before, and I actually showed what happens. There's an infinite loop going on. Hopefully, we'll see if you can spot why. But let's say I'm looking for 50 in here. We're not going to find 50. Our code doesn't handle it. And the browser just keeps looping over and over and over. And with my recording software, plus the browser doing that, my computer was really not happy, and it got like 1,000 degrees. So I'm not going to replicate it here. But what would happen is that we would get basically thousands and thousands. Eventually, it would be shut off, but tens of thousands of iterations, if not more, because we're never going to find that element. And the only way our loop ever stops is when we find it. If our middle index is equal to the element, we break out. But our middle index is never going to be equal to, or the item at the middle index is never equal to 50 or 1 or 14 or any number that's not in here. This is going to go forever. So what's our other stopping condition? Well, if we look at what happens, as we approach a number that's not in there, we do the same thing, right? 2 is our start, or 0 is our index. This is our end, 7, and this is our middle at index 3. Well, we check 50 is greater than 9. So we move the window up to here, as you see there. So now our start is 13, or index of 4 up to 7. We take the middle, index of 5, and 50 is still greater than 15. So now we move up again, and this is our new window. And our middle is 28. And we check, is 50 greater than 28? It is. So what's our final iteration going to look like here, or what should it look like, is that we're going to move the start to be middle plus 1, which is 30. So then we end up with everything, start, middle, and end, all at 30. We've hit the end of the list. So then what's next? Because our code is still saying, all right, well, the middle is 30. We're looking for 50. So we need to move the start to go up 1. And there isn't anything after that, but it's going to increment our start, or it will increment our start to be 8 at that point, which is out of bounds. So then if we tried to do that array of 8, we're going to get undefined, and then we're going to start comparing things with undefined, and it's just not good, and it's going to keep going forever and ever. So we don't want that. Okay, fine. I am going to show it to you what happens, and my computer's not going to be happy. Here we go. As you can see, it just keeps going and going over and over, and it sets the start now is 8. Okay, I'm back after my computer's not very happy with me, but it worked out. So what happens at the end is that our start, middle, and end converge, and then our start gets above. Our start is set to be middle plus 1. So the next time through, if we're working with the start is 8, the middle is 7, and the end is 7, if we go through again, we're checking is the array middle, which is still 7 because we take the average of these, 8 and 7, and you floor it, and you're still stuck with 7. So our middle is not going to budge, and it stays at 7. And then we go through again. Is element less than array middle? No, it's greater than, because we're looking for 50. So 50 is greater than, so we get start equals middle plus 1. So start is 7 plus 1. So we're not moving anything, and we get stuck because we've hit the end, basically, and we've crossed over, if that makes sense. Our start has eclipsed our end, and it's stuck that way. We're going to continually set this to be 8, the start will be 8, the middle will be 7, and it just keeps going over and over and over. So we want to stop. We want to make sure this loop only runs while our start is less than or equal to the end. So as soon as the start becomes greater or the end becomes less than, we have a problem. So just in here, I'm going to do and then we just check start is less than or equal to end, just like that. Okay, so we're close now, and if I run this time, we still have a problem, which is that we're returning the middle even if we don't find it. So now we don't loop forever, but it's returning index of 7 because that's where we stopped, right? That's our last point right here. So index of 7, but that doesn't work because 50 clearly is not at index of 7. So now we just need to add a little check at the end. We want to check basically if array of middle is equal to what we're looking for. Oops. Like that. If it is, then we return middle. Else, what do we want to return? We'll return -1, I think is what we said, right? Yes, it is. Does that make sense? So we're checking if the array middle, the item at the middle index is what we're looking for. Should do triple equals. We'll return middle, otherwise return -1. So now we get -1. But if we search for 5, it gives us 1. If we search for 9, it gives us 3. If we search for -1, we get -1. -10, still -1. Okay, so a couple small cleanup things we could do if we wanted to. We can, well, first get rid of the console.logs. We don't need that. Next, we can condense some of these conditional statements. So I'm going to duplicate the solution because some people like to have a longer version, but I will also do a shorter version where we get rid of basically a lot of white space like this. So do a single line if statement, and then our else doesn't need brackets either. So there's one reduction of a couple lines, and then we can also put all of this on a single line using the ternary operator. So that looks like this, or there's two implementations. So we can just do return array middle equals element. If that's true, so we need this question mark, we're going to return middle, colon, else we return -1. If you haven't seen that syntax, the way you would read this is return the result of this whole thing, first of all. And the result is going to depend on if array of middle is equal to the element. So if array of middle is equal to element, return middle. Else, return -1. So just test it out again. It looks like it's working. Let's plug in a number that is in there, like 30, and we get index of 7. If we plug in 13, we get index of 4. If we plug in 103, we get -1. Okay, so that's our shorter solution. All that we did, the logic's the same. We just got rid of some of the extra brackets and the longer if statements. So we made it through there. Hopefully it makes sense how this all works. And now we're moving on to a couple other searching algorithms. So keep in mind this works great on a sorted array, otherwise it's useless. So linear is the best that we can do. What we saw a couple videos ago is the best we can do on an unsorted array. Binary though works great if our data is sorted.